Unit 4 Chemistry, Chapter 16, Part 2, Denaturing of Enzymes. So if you remember back to when we've looked at amino acids, you remember that amine groups on amino acids can accept protons and carboxyl groups can donate them. Okay? If you've got amine and carboxyl groups on the Z groups, it's going to behave in exactly the same way. So in a neutral solution, which is isotonic or appropriate for that particular amino acid, the amine will accept and one carboxyl will donate. Doesn't matter whether they're in the main part or in the Z group, but you'll get one positive and one negative charge. As soon as we add or reduce the amount of hydrogen ions there, that balance will change. Okay? So this would be not in solution. As soon as we add it to solution, we get our zwitterion being formed. Okay? If it's a low pH, it'll turn into the cation form. So we've got more hydrogen, so we add one to there. If it's a high pH, then we have fewer hydrogens, so this loses its positive charge and that stays negatively charged, so it becomes an anion. Now this is important when it comes to enzymes because remember that when we are holding the substrate in the active site, we may well be using some ionic attraction to do that. Yeah? If we are holding the tertiary structure together, again, we're using some ionic bonding to do that. Or maybe some hydrogen bonding, but a lot of bonds that depend on charge. So if we change the pH, that changes those bonds, and it changes how well we can hold the substrate, and our active site no longer works. Okay? So this is an optimal pH for this particular enzyme. It's different for each enzyme. As soon as we move away from it, our enzyme activity falls because the shape is no longer appropriate. And it becomes what we call denatured. Okay? There is no such thing as renaturing. Can't go backwards. Once it's denatured, it doesn't work and you're stuffed. Similar thing can happen with temperature. At low temperatures, we're getting a low rate of reaction. Now this is going back to collision theory. Okay? Remember that as we increase the temperature, we increase the kinetic energy, so we're therefore going to get a greater frequency of collisions. In this case, collisions between the enzyme and the substrate with the correct orientation. But once we get past our optimum, we are giving the bonds too much energy and they're vibrating and vibrating and vibrating and they pull apart from each other, particularly our weaker ones in the tertiary structure, like our dispersion forces. So here we are denaturing the enzyme. Gets too hot, the bonds in the tertiary structure break, so the shape of the active site changes. Okay? So this is our active enzyme. It denatures and it then forms a new shape. So if we cooled it down again or change the pH back to the optimum, it will make new bonds, but not the right ones. So it's going to not go back to the original shape. And that's why we don't get renaturing. It's just not a thing. We can measure enzyme activity and therefore measure whether it's becoming denatured or not using rate of reaction. To measure rate, we need to measure some way the activity and time. So we might measure how long it takes the blue-back colour of iodine to stop appearing, indicating that the starch has all been broken up, for instance. Or if our enzyme is producing a gas, how long it takes for that certain volume to be made. Enzymes denature, so we're breaking the bonds in the tertiary structure, but the molecular formula remains the same, and our primary structure is not changed. On the other hand, if we hydrolyze a protein, we break that primary structure, we break the amide links, and break the covalent bonds. So hydrolysis happens in your digestive system, so you can then absorb the amino acids. Enzymes can become denatured in any cell if the conditions change and become wrong.